Okay. So our next paper is entitled "The Need for a Meta-Architecture for Robot Autonomy," and the speaker is Stalin, right?
Yes, yes.
Thank you.
Yes, you can call me Stan. I didn't decide my name, of course. Well, today I'm talking about the need for a meta-architecture. I'm currently a PhD student at the Autonomous Intelligence System Group in the Institute of Software Technology at TU Graz. And my supervisor is Professor Gerald Steinbauer.
Oh, it's the one on the bottom. There's the, yeah.
Okay, thanks. So, well, I'll try to be brief. This is the outline of the talk. Basically, you can find a lot of detail in the paper. I mean, today I learned a lot also about some of the tools I didn't know, so it is amazing. Thank you for making this happen to the organizers. Architecture are a really hard thing to do in general in software, so I'm going to try to just go over the main topics regarding robotics and different concerns which are usually not addressed. So, well, we all know when we work with robots, there are lots of different adversities that the robot needs to face. Some of them need to do with the environment. If the environment is diverse, uncertain, partially observable, even it can be not cooperative. So there is a lot there that makes it really, really hard to guarantee a safe behavior of the robot. But there's also problems with the belief state of the robot. And usually this is not really easy to come out with a good solution to it. I mean, so already we saw today some epistemic effects and knowledge-aware robots, and I mean, there are bits and pieces all over the place, but I mean, how do you engineer an architecture which is reliable in these dimensions? It's hard to tell. I mean, there is no really an easy answer. Well, there's some definitions there, but the main point here is dependability. Dependability is a very well documented concept in engineering, and especially for software systems. And we are talking now about the dimension of software within the robot. Dependability is highly correlated with reliability, which is what brings us here to make the robot trustworthy. And we need to guarantee the behavior. Dependable autonomy might seem a bit of an oxymoron, but what we are saying here is that we can depend on the independence of making right decisions. So there are different things. I'm going to skip this, but basically the idea here is to make a call to the community to go or move forward to a standard, because I mean, you can find hundreds, literally hundreds of works of different architectures in different with different emphases and different domains. So it is really hard to come out with a unifying meta model, if we want to call it. And I think we have all what is needed. We just need to come together and work towards that standard. I think no research group in the world can handle the size of the problem. I mean, if we work in small pieces, but we coordinate and we make it interoperable, it will make a big difference. So that's my main point here. And there are many different architectures from decades on, and very successful ones, and some interesting things I'm not gonna say here, but there are, of course, a lot of challenges. But if we can come together to these agreements, they don't need to converge to a single implementation. The idea here is it is at a very abstract level, so we can define all these meta models in such a way that they are platform independent, so everyone can still work with their own implementations. And there are lots of different drivers for these are our desiderata, and they are not all of them. of course, putting together, even for a software architect, which usually takes a decade to become a very well, say, mature software engineer, if you ask him to design a robot which fulfills this, it will be a hard time. I mean, we don't really know how to do it. I mean, it takes literally decades to do it. So how can we facilitate this? I think the way forward is towards defining this standard. It is too big, too many concerns. They need to be put together. And I think I see some different approaches, but I think model-based engineering is a very, I think is what has convinced me the most, because it comes with a nice set of tool chains that can automate the process. I mean, if putting all of these concepts together only can be done by machine. So we don't design our computers by hand, but we are still designing our controllers by hand. And so I think by relying on this automation, or in a few years, we can achieve a lot. This is an example. We have been working with different architectures, but of course, we also have the implementation by hand. We are not in the stage of integrating this, especially because when we move into the cognitive abilities of the robot, it becomes very blurred how to put them together. So we can start with a very minimal definition of what this meta-architecture can be, and then work towards including more and more elements as we understand more about it. We work in different use cases. Here is one of them. It is the Robot Hub Logistic League, which is with real robots, but we have also the simulation environment, and we try different things there. We currently are working towards defining our architecture for these environments, but we want it to be also domain independent, so that we can use it here, but also in our other robots, which are completely different use cases. So that's a desirable thing. This is just model-driven engineering. Today we was say a lot about it, so I'm not going to go into the detail there. What we found is sufficient evidence. We believe it is very clear at this, for me, that there is already a lot of different solutions to the specifics, but putting things in a consistent, organized way is what is lacking most of the time. I mean, there are excellent already meta models for addressing the engineering aspects, but when we move to deliberation and cognitions, is not so clear. So we need to also bring down the semantic gap, close down it as much as we can, and facilitate this. And of course, the main argument here is cost. By automation, we need we usually reduce the cost significantly. And we cannot do that without models, and we cannot do it by hand. That will be the idea behind this. I already mentioned all of these things. That is already said. So I don't know if there are some questions. I don't.
Thank you very much. That was free. Are there any questions?
So I love, the idea, and I love the examples. Remote agent is dear to my heart, especially. But is there a concrete suggestion here, or are you kind of saying, yeah, we need to do it, but kind of leaving it very vague?
I mean, there are already concrete pieces, and I mean, in the paper you can find some of them, but they are not either. I mean, the communities are divided. So the cognitive scientists do their architectures trying to test hypotheses, and engineers do their architectures trying to solve problems. But they are facing different challenges, of course. I think we need to to transfer this, to transform it into concrete things for engineering. I'm an engineer myself, so I'm in this side, but I understand for deliberation, it's already autonomy can at the interesting levels cannot be done just using engineering as we have done so far. I mean, we need to bring this knowledge from the cognitive scientists into some engineering understanding, and that even the language is a barrier there to make the right interpretation of, and it's a lot of, I mean, all of these concepts need to be together. So I think automation is only, I mean, without it is impossible as far as I can see.
Any more questions?
I'd like to ask a question, if that's all right.
Yeah, please go on.
Thank you very much for the presentation. Let me just start by saying that I agree entirely with the statements you made about the state of the art on architecture. In Robostar, we are developing a notation or meta notation to allow colleagues to specify their architecture via patterns and then generate design models, formal design models automatically, following the approach that we're encouraging here. One thing, however, that we found, and I wanted to know whether you agree or not, is that one common thing, one common trend between all these different architectures that are being used by colleagues is that they are all layered. Sometimes layered in different ways, but layering seems to be the trend.
Yes, that is true. That is because most of the time abstraction is required in the hierarchical organized manner. That is because we are still doing it by hand, I think, mostly, but this is only affecting the design time. There is also a runtime aspect of it. And I mean, in that regard, there's a lot of research to do in terms of the dynamic architectures, reconfigurations, and fault tolerance, I think can only be achieved by dynamic architectures. And the role of reasoning there is not so clear. And also the maths, I think category theory is one of them, but I'm not really knowledgeable in that field. I think this is a more cognitive constraint by the human. I don't know if it is, of course, it facilitates and is implicit in the compositional approach of robotics, but I'm not sure that it will scale when we are talking about the integration of all the cognitive abilities to achieve autonomy. In that regard, I think my compositional ability might not be sufficient. And what I can see is dynamical system theory might make a difference. But I mean, this is going to explode if we start to think about it. So I think we should go slow and try things and progressive in small steps, as engineers usually do. But there's a lot to do. But I think the only way to make real progress is by working as a community, because it's too big and too complex a problem for a single group, and it's too costly. I mean, nobody will be able to afford it. So, but if we do small pieces and we just agree on interfaces and different languages to describe, and we have the tools to translate, I think that might work. In the long term, I can see this might make a big difference.
Thank you.
Thanks. Thank you again.